Hi everyone, I thought it was about time to do another video. I didn't want to do another devlog just yet. I've got a few things coming up in the pipe that I want to hold off on to do another update on Kwyll itself. But having just come back from RetroFest 2026, a really interesting event with lots of interesting Kwyll. One of the things I did for RetroFest in particular was put together a series of games, that some of which I created, some of which other people had created, and showed them on the table, on the stand, so that people could play and have some fun. I had a few to show, but wanted at least one more, so I asked on the Discord, anybody got any ideas for a game that could be put together fairly quickly? And one was suggested, which is a game called Head On by, I think it was by Sega Gremlin, back in 1979. Looked like an interesting, fun challenge, so I gave that a go and threw something together. So what I want to try and do on this video is just quickly go through how it works. It was quite popular at the show. People enjoyed playing it, and it's fairly faithful, I think. Having never played the arcade game, but seen lots of videos of it, I think it's fairly faithful to the original in terms of gameplay. So I want to just quickly go through how I threw it together. It was thrown together fairly quickly, so I'll make. Okay, so I'll dive into how it works in a moment, and what the way that I've designed it or implemented it. Please don't use any of this as a de facto guide for how you should do certain things. It was thrown together fairly quickly. I'm sure there are better ways of doing various bits and pieces that I've done here, and if I was to spend more time on it, I could probably come up with them, but it worked, and it worked fairly quickly. So hopefully you can take away some lessons from this, some tips and techniques, looking at the way that I do things, and maybe come up with some ideas of your own. If anything I explain isn't clear, or you want any more detail, by all means drop a comment in the comments below, and I'll respond as soon as I can, or even better, pop over to the Discord and ask there, and I'll respond in real time. So before I show you how I did it, let's just have a quick look at what it is. I'll see if I can play the game briefly for a second. So it's a dot munching game, Pac-Man style, and apparently it came out before Pac-Man, 1979, I think I said. So you've got a car that's constantly moving, so you can move at normal speed or fast speed, but you can't stop. And all you've got in terms of control. So I'm the green car, and you can see I can change lanes in the areas between the tracks. If you're going, the idea is to avoid doing what I just did, which was crash into the opposing player. So you can go fast or slow using the fire button. When you're going fast, you can only change one lane. When you're going slow, you can change two. And apart from that, staying alive part, you've got to try and collect all the dots. And it gets progressively harder as the enemy cars get faster and more. Well, two. And collide with me, and I've got to keep out of his way. Collect all the dots. When you're moving slow, you can traverse two lanes like that. When you're moving fast, you can only do one. But here we go. So what happens when you crash? So the idea is to collect them all, collect all the dots, avoid crashing. You have 3 lives, and as you go through and complete each level, it gets progressively harder, and eventually you have 2 cars, and they get faster, and it just gets more difficult to continue playing. Fairly simple game. So I'm going into a little bit of background about how I came up with the final design. I did run through a couple of tests first to try and get that racing mechanic working, that basic control mechanic. They worked, but I wasn't entirely happy with them, so I landed on something slightly different. But if we go to the rooms, the most important thing is when you're in a room, in this room, so you can see the track is designed here. If I turn on the collisions, you can see that all of the barriers are marked as impenetrable, so you can't get through the barriers, so I don't have to worry about any of that. The dots are just tiles, so they're very simple, and I'll show you how we do the collection on that. But the difficult thing was, or not the difficult thing, the thing that was open to different interpretations was how the car, because the car is largely autonomous, it will continue around the track constantly on its own without any input from the user. The only input you need is when you're in these gap areas here to change lanes. So how was I going to make it go round the track properly? The first attempt I had was to put markers. So if you've used Kwyll at all, you know you've got these markers that you can place here. So I placed markers all over the place, at the corners and at these entry points for each track into the area that you can change lanes. And I used those marker positions in logic with the car position to determine whether you should turn around a corner and whether you can or cannot change lanes. And that worked, but it was a bit messy, and I ended up with, well, you can imagine I had 4 markers per lane for each corner, plus 2 for each entry point and exit point of the sliding areas for each lane. So you had markers all over the place, and it was a bit of a mess. It also means, because there's no way in Kwyll at the moment to actually reorder things, it was a bit of a fragile design, in that if I decided to add a marker somewhere else, the logic could be much more difficult to manage. So I tried a few other things. I tried entering coordinates into variables, initialized variables on the logic, so you could define it that way and just go in and change them, but then you're entering lots and lots of numbers. So in the end I've settled on a slightly different way of doing it. So you can't see it here because I've hidden them, but there are 3 tiles in the tile set that have nothing in them: 9, 10 and 11. And if I put something in there, you can see that there's one of these at each of the corners. And for 10, these are for the areas in which you can slide left and right, and 11 is the areas that you can slide up and down. So by using these invisible tiles, and you can see from the indicator here, they've got type 2 and 3 for the slide, and I don't need a type for this, and I'll show you why in a moment. But 2 and 3 are for the sliding areas, and tile 9 is for a turning point. So what I ended up doing was, when the car object, during its movement logic, where it's moving along the track in a certain direction, as soon as it hits and is entirely within a tile, I check to see the tile type and the tile index underneath. And if it's a turn tile, then I change direction according to which direction the car's going and where it is. And if it's one of the type 2 or type 3 tiles, then I set a flag on the logic to say the car is able to change direction, to change lane at this point. So that was a much simpler way of doing it, because then I can just paint these tiles in. And it also allows me to do things like, if I wanted a different track design, I could do that, and it's a lot easier to manage. So that's what I settled on for that. So with that, it's probably the easiest thing to do is to get into how the car logic works now. So you see I've only got 1 object, even though there's 2 car types. I decided early on to incorporate both enemy and player cars into 1 object. And there's a flag on the variables that says whether this particular car is the player or not. So if we go back to the room again, you can see we've got 3 cars on here: player, opponent 1, opponent 2. And if we bring this up, this one is set to player, and these 2 are not. So that's how the logic determines which type of car it is. So there's some things that are common for all cars. The going around the track bit is common. Both cars just automatically go around the track. They all check for interpenetration with the other cars and cause a crash. and so on, and they can all change lane, and they all need to know which lane they're in. So that's all common code. That's why I decided to do it all in one object. And then there's two separated parts that are only come into play for the player or the enemy. So if I go through each of these tabs in turn, so this is the I'm not going to go into huge detail, but I will cover each flow so you can just get a handle on how it works. So in initialize, this is what happens when the car's first created. It just resets a bunch of things. You see from the red indicator here, I've got some subroutines in the shared logic. I'll go into those in a moment. So this basically just takes the current position and the velocity and works out which lane it's in, and then stores that in a variable on here on the object itself, so that the object knows which lane it's in. And if it's the player, stores it in a global variable, the player lane. And the reason for that is the enemy cars need to attempt to get to the player. So in order to do that, they need to know where the player is. So anytime the player car changes lane, if it is the player, or anytime a car changes lane, if it is the player, it updates that variable so that the enemies can look at it. So that's a very simple initialization. And then we have this code here is for the player only. So this is if the this is not the player only. This is for all cars. Again, this is for the movement around the track. So each car gets an X and Y velocity and a direction. So you've got these, where are we here? X and Y velocity and the direction. Now the direction is, it may be counterintuitive. You may think the X and Y velocity gives you the direction, but the direction is slightly different. The direction is whether the car is going clockwise or anti-clockwise around the track. So the enemies typically go clockwise and the player goes anti-clockwise. And you need to know the direction because when you're doing things like turning at the corners, you need to know whether you're going clockwise or anti-clockwise to determine which the next direction is. So in this logic here, we take the X and Y velocity, we use the speed here, so the cars can travel at different speeds as well. Both enemies and player can travel at different speeds. And then that works out the new position. So we're adding the velocity in X and Y multiplied by the speed to the current position to continue moving it along the track. And then after we've done the move, we have to check. So these two branches here, one is for if you're moving horizontally versus vertically. And what these do, I'll just touch one of them because the other one's the same, but just for vertical. So this is horizontal. So basically it'll get the current position and work out if it's exactly on a tile, because we only want to check for direction change if you were not precisely on a tile before, but you are now. Otherwise it'll be constantly trying to change direction every time you're touching a tile. So here we first of all check to see if we're exactly on a tile by taking our X coordinate, adding it with 7. Excuse me. And if it's 0, then we're exactly on a 8 pixel boundary, so we're exactly on a tile. And if that's true, then what we want to do is get the tile that we've just moved on to by using pixel to tile to convert our pixel coordinates to tile coordinates, get the tile information. And we're interested, for turning in particular, in the tile itself, because if you remember, the turn tile doesn't have a type ID, but it is only one tile, and it's type 9. It's index 9. So we check to see if it's index 9, and if it is, then we message the object ID 0. We use a lot of message passing in this because it's a convenient way of doing things. So what does message ID 0 do? It takes no parameters. So this is where we go to another tab, and in the turn tab we've got this monstrosity. It's not as complicated as it looks, and this is one of the very particular areas where with a bit more time I'd probably clean this up, but it works, so I'm not going to touch it. So this is message 0, which basically means turn. You've hit the tile that indicates you've hit a turn point, a corner, and you need to change direction. So the first thing it does is work out which direction you're going, clockwise or anti-clockwise. And each one of these, again, is the same, but just tweaked for each direction around the track. So I'll just have a look at one of them. So it's worked out here that we're going, let's say this one's counterclockwise. So it's worked out that we're going counterclockwise. Then it needs to check which direction, whether we're going vertically or horizontally counterclockwise. So that's what this does. Gets the x velocity. If it's 0, if it's 0, then it's presumed to be moving vertically. If it's not 0, it's presumed to be moving horizontally. And again, these two are the same, but one for vertical, one for horizontal. So we just look at focusing on one of them. And all this does is it gets, so this is presumed that we are now moving vertically, and we've hit a corner and we're going counterclockwise. So by this point we know we're going counterclockwise and we're going vertically. But we don't know yet whether we're going across the top or across the bottom. And that's determined by the x velocity. So if you're going across the top and you're going counterclockwise, then the x velocity will be negative. If you're going along the bottom of the track counterclockwise, then the x velocity will be positive. So that's what this check does. So again, we're down to just one set of things here. These two are the same, but one acts if you're going across the top and one acts if you're going across the bottom. So by the time you've reached this point, we know we're going counterclockwise. Let me see what this is, less than 0. So we know we're going counterclockwise across the top, and we've hit the corner. So we've hit the top left corner of the track in this example. So then we just set the sprite animation, which turns the car around. We set the x and y velocities to the new values to say we're going down the left-hand side of the screen. And that's all these do. So they all do the same thing, just depending on which direction, which part of the track, so which vertical or horizontally, and which part of the track you're going around. So although it looks fairly complicated, it's actually quite simple. It's just replicated a lot. So that's basically what happens to do a turn. I hope that's fairly clear. All it needs to do is change the animation so that the car spins and change the direction of movement so that when it comes back to doing this part here, is moving in the right direction again. It's moving in the right x and y velocity. So that's basically what a turn does. We've got one more down here, which is, just see, this is for player only. And this is the speed. So basically this is if the fire button is being pressed, then we set the speed to the double speed. Otherwise we set it back to normal speed. So if you remember when you're playing, if you push the space bar or the fire button, the car speeds up. So this is just setting the current speed based on whether the fire button is held or not. So that's that one. Turn we've touched on, we've covered that already. So this is the tab for things to do with lane changes and the current lane. So this bit up here runs every frame, and if you remember, I said that there's these special tiles here. They indicate whether you can or cannot change lane. So this is what this is checking. So it's basically checking if it's this is where I've clearly made a conscious decision but not backed it up with changes to the logic. So if you remember, I said that these have type 2 and 3. Turns out I don't use the type 2 and 3 at all. I just use the index 10 and 11. So that was a bit silly, but there you go. So one more time here. So this will check to see whether you're on a type 10. If it is, it sets this flag here, can slide X, to 1 if it is type 10, index 10. If it's index 11, it sets can slide Y. So we can see this if I quickly just show. I'll slow things down so you can spot the variables properly. So if we move down to this, the data view, we find our player object, which is a room object, and we've got these two variables here, can slide x and y. So if we watch those as we play, so if I slow it right down as you get to there, as soon as you enter into that area, you can see the can slide x variable turns to 1, so that means it can, while it's in that area, it's able to actually execute a horizontal slide between lanes. And the same logic applies to the enemy car, because it needs to know when it can as well. So if we scroll down a little bit and look at the can slide x and y on opponent 1, and then just stop it and start it again, is probably the easiest thing. So if you watch our opponent values, you'll see that as the enemy car goes into that area, it should switch on as well. So you can see that go to 1 and then to 0 as it exits. So that's what that small bit does, just sets or resets those flags, and then the rest of it is down here in this this code here. So again, this is only happening if it's the player, because the lane change is done by the AI for the enemy. So we have this bit here which basically grabs the input from the controller left, right, up and down, and these are portals. They're documented in the documentation. They're just a simple way of decluttering your logic a little bit. So this one comes into the X direction and the Y direction. The adds are so that if the player is pressing left and right at the same time, they cancel each other out, so the X direction then will be 0. So once we've gone through here, we've worked out we are the player. This is capturing the direction into XD and YD. And then we've got 3 possible routes through the rest of this. If XD is not 0, which means you're trying to change lane horizontally on one of the 2 sides, then we first of all check if you can, using the variable that was set up up here. And if you can, then you make the screech sound, which is just a sound for when you're sliding across the lanes. And then we just add the X direction into X and move the object. So that's simple. If X direction is 0, then we do the same for Y direction. Exactly the same thing, do the screech sound and move it in Y by that amount. And this is why we've got 2 here rather than 1. So you're moving 2 pixels at a time. That's how quickly it moves across lanes. Finally, if X direction and Y direction are both 0, which means the player isn't trying to change lanes at all, the next thing is let me show you what it does. So I'm going to set the speed up to something that I can manage for a moment. So as you can see, if I try to change lane but don't quite make it, it snaps back to the other lane or to the next lane, depending on how far you'd actually manage to travel. But it will always snap you into a lane, so you're safe. If we go back to our lanes, so this will say the player isn't trying to change lanes anymore, so they're not pressing left, right, up or down at all. It will first of all check to see. It uses this subroutine. Again, I'll go into subroutines in a moment. This subroutine is responsible for snapping the current position to the nearest lane. So it'll only work if you're not on a lane, but it will snap you to the nearest lane. And it works because each of the lanes is 16 pixels apart. So we've got 1, 2, 3, 1, 2, 3. So it's 16 pixels between each lane center. So that subroutine will snap to the nearest 16 pixels. I'll go into how it does it when I look at the subroutine itself, but basically that's what it does, and it transports it. So we don't want to do any collision detection here. We just want to snap it into the correct lane and and let it carry on moving in that lane. And then the next thing it does is, because you have changed lane, it does the same thing it did back at the start. If you remember, we get the current lane, store it in the lane variable here so that the car itself knows which lane it's in, and if it's the player, store it in the player lane as well, so that the enemies know where to look. So that's lane logic. Again, it looks fairly complicated, but it's quite simple. It's just 3 branches, moving in X, moving in Y, or not moving at all. I'll come back to the AI in a minute because that's very similar, but let's complete the player stuff first. Dots is incredibly simple. As I said, in the room, these dots are just tiles with a type of 1. So if we look at the dots logic again, we have a touch tile, which, for those who know, will trigger only if an object is over a tile that has a non-zero type. So that's where we do need the types. So this will say if it's the player, first of all, because we don't want the enemy to be collecting dots. So first of all, it checks to see if you're the player. If you are, it checks if the tile type is 1, which is the dot. If it is, it clears it, so it just wipes it off the map altogether. Messages the global logic with an ID of 2, which is, if we go and quickly look, message ID 2, which is dot collected. So the global logic will take care of recording that the player has collected a dot. And then play a beep sound to say that you've collected. That's all that's necessary to collect dots. And the last thing is another fairly simple one, which is collision. Now, so basically, if any car hits another car, the only object types are cars, so they're going to be hitting another car. So the first thing it does is any object involved in a collision, so the 2 cars involved in the collision will get this trigger, both of them. And the first thing it does is make it invisible, so it just hides it from the screen altogether. And then if it's the player, because we only want to do this once, so if it's the player, then message the location with ID 2. So if we quickly look at the logic for our room, it has a message 2 here, message 2 handler, which is crash. And that's responsible for doing the crash animation, which I'll go into in a moment. So that's what that's basically doing. We only want to do that once. We don't want to do 2 lots of crashes and sounds and everything. So it's just checks to see if it's the player. Now, just to make sure that it's clear, if we go to the room again and we look at the player car, you'll see the player is on layer 1 and it checks layers 2 only. And the opponent cars are on layer 2 and checks layers 1, which means the opponent cars won't check against each other, which means the opponent cars can't crash into each other and trigger that same logic. So that's why we don't need to do that. We don't need to check for that. So that's all the crashing is. And the last thing to cover is the AI, which is the enemy player logic. So what this does, excuse me, what it does, there's a couple of things it does here in the AI. First of all, you may have noticed when playing that when I was playing that the enemy gives the player a head start, as it were. It's a slight delay before it starts racing. If I play, you can see there's a short delay. So that's what this does when the car is initialized. If it's a player, if it's not the player, it will decrease that delay, which is initialized by the room, and only start moving or only set the speed to something other than 0 once that delay has reached 0. So it's just a stall, if you like. And then we've got here, this is the logic for determining whether to try and slide or not. So this is a little bit complicated, but I'll go into it. So what I decided to do was when the enemy hits an area where it can slide, it will try. But what I didn't want to do was try and then try again and again and again. So it will try, and then after it either succeeds or fails switching lanes, it'll initiate a timer to say don't try and do it for a random amount of time. Otherwise, you're just constantly changing lanes. And it might change lane and then try and change back again within the same region. So putting in a small timer just made sure that it tried to change lanes once, succeeded or failed, depending on when it started, and won't try again for a short amount of time. So it just it's like a hysteresis. It prevents it jumping around too much. So that's what this is doing here. If there's a delay counter, it just reduces it and only allows the check to see whether we can slide after that delay is completed. And then it sets it to -1 if it's not. It decreases it by 1 if it's not already at 0. If we've reached 0, then we can check to see if the enemy can slide. So this is very similar to the logic on the player, where it was checking to see whether it was possible to slide in X or Y, but it was responding on the player to user input on the joystick or the controls. Here it's just basically saying, am I in a position that I can try and change lane, and if so, so let's say if you can slide in X. So each one of these again is very similar, but one for X and one for Y. So what it's trying to do here is, this is where we get the information about where the player is on the track. And if you remember, there's a couple of places where the player changes lane, and it stores its lane information in a global variable, player lane. So this is where the enemy is checking to see where it is, lane 0, 1, 2, 3 or 4, compared to the player, so that it moves in the right direction. So if it's so what it's doing here is, first of all, it starts to it presumes initially that it's going to try and increase the lane, and then it checks to see if it needs to decrease and sets it to -1. So it sets it to 1 first to go up a lane. If actually the player is in a lower lane number than the enemy, it will set the sliding in X to -1. If they're the same, so this is less than, greater than. If it's not less than, it's not greater than, then it's the same. Then it doesn't bother sliding. So if you're already in the same lane, don't try to slide. So what this is basically ending up doing is setting the AI sliding X value, which is these two here, X or Y, to -1 or 1, depending on which direction it should go to try and reach the player. And then it sets a counter 16, and that's because, as I said before, it's 16 pixels between lanes. So by setting this counter to 16, it will try and move 16 pixels in the direction that was decided before stopping. And that's what this bit down here is doing. So this is this happens after the try to move logic, and this is, are we moving? If so, if so, continue the movement. So we check to see if we're sliding in X, and again we've got the same pattern here where we've got this and this are very similar. One is for vertical, one is horizontal, and all this does is work out. This is doing the same thing that the player was doing with working out which lane and which direction to move. So if the Y velocity, based on the Y velocity or the X velocity, it will determine whether it needs to move. Sorry, the Y velocity. So you're changing lanes horizontally, so you're in either of the two side ones, but you need to know whether a negative change in lane, from the left side of the track will be moving in one direction, but a negative a change in lane from the other side of the track will be moving in a different direction. So it needs to work out whether it's going up or down either side of the track. And that's what this is doing, and it just moves the object, much like the player control moves the object in X by 1 pixel each time, each time 16 times round. And then the same thing for if you're changing lane vertically. And then this all merges into one where it just reduces the counter so that it only does it 16 times. Checks again if it's at 0. If it is, it does very similar to what the player does when the player car does when the player stops sliding. It snaps to the closest lane, sets the current lane value, and then clears out the sliding information so it's no longer sliding. So that's basically the logic behind how the enemy behaves. It will just, in a nutshell, it will. It already knows whether it can slide X and Y because that's common for each car, for all cars. It will check to see if it's outside of the delay. If it's outside of the delay, it will check to see whether it can slide if it's on a part of the track that allows it to change lanes. And if it is, it tries to work out which lane change it needs to make to get it closer to the player car, and makes that change over 16 frames. And then the last thing we've got here is this happens when you start the level. So it's a message sent by the room to the enemy cars, and so it only happens if it's not the player, and if it isn't the player, it sets the maximum speed to one of these values, and these values are chosen based on the level. So the levels are 1, 2, 3, or 4. 0 isn't a valid level, it starts at level 1, so that's just a nonsense value in there to make it easier. So it reads in the level from the global variable and chooses a maximum speed of 2, 6, 2, or 6. So on level 1 it's 2. On level 2 it's one car with a maximum speed of 6, so it goes a lot faster. On level 3 there's 2 cars enabled and each one can only go maximum speed of 2. And on level 4 and beyond, because it's clamp, it will be 2 cars driving at maximum speed 6. So that's just setting the maximum speed to the right value for the level that you're playing on. So I think that covers pretty much everything for the cars. Like I say, there's a lot in there, and the reason there's a lot in there is because this same set of logic works for both player and enemy. And the reason for doing it that way rather than having a separate enemy car and a player car is there's a lot in there that's common, such as driving around the track in a circle in one direction or another, changing lanes. A lot of that logic is common, and I'd have to duplicate it if I had 2 different cars. So I chose to have it all in one and just have the turn and the AI part specific to player or enemy. And that, in all honesty, is pretty much the entirety of the game. It's all in the logic on the player. There's a little bit on the rooms, which is just housekeeping, really. So there's a bunch of things up here which... so this just resets the variable for the number of dots. So I know there's 176 dots on the standard track. By setting that to 176 there, as they get collected, I know when the level is complete. Level 0, message 0 is a pause, which is sent to the room when you crash or complete the level, and that just basically sets the all 3 cars to inactive. You can see the flag is set to off, 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 which means none of the logic on those cars will run. So it just stops them moving. Start is the opposite of that, sets them all to active. And then there's one slight difference here for start. It only enables and makes visible the second car if it's greater than level 2. So the second car only comes into play at level 2. And you saw I mentioned the message that gets sent to the enemy car to set up its maximum speed. That's where this happens here. Message 1 goes to the enemy cars to set up their maximum speed based on the level. This is what gets sent to the room when the cars crash, and these two they work in combination. So this one receives the message, works out in tile coordinates where the crash happened, and stores them in crash X and Y, and then sets a counter to 10, and then messages the location with ID 0, which is the pause we had up here. So basically pauses all the cars, so no more car logic will continue. The cars won't continue running around the track. And then if that crash counter, the counter that's set to 10 here, is non-zero in this always flow, it will flash. The way I did the crashes is I transferred, rather than do lots of big sprites, I transferred the bitmap for the crash image into a bunch of tiles and created a brush. If we go to the scratch pad, you can see where I did it. So that's where I created this brush, and then coloured it. Grabbed the brush, coloured it differently, grabbed a brush. So I've got all these colours for these brushes, and in the room logic, it flashes, it cycles between randomly those 6 brushes, just using a where are we? Yeah, random 0 to 5. So it pastes the brush at the crash location, one of these 6 brushes, reduces the count. If it's equal to 0, it messages the global logic ID 1, which is the crash, and in this case it means the crash has completed, the animation is completed, and it's time to reduce the lives, pause, and then reset the game if you've run out of lives. And if it's not equal to 0, so we're still doing the crash animation, just play the crash sound, and that's how you get the flashing crash animation with the multiple sounds. So that's all there is on the room. The game logic has a few bits and pieces on it. Again, housekeeping. So initialize, we've got a few things that set the score and the and lives to an initial value. We set a delay. Can't quite remember what the delay is for. Come to me in a moment. We message global logic. So we've got a handler here for when we go to the next level. So the first thing you do when you initialize is go to the next level. So this just increases the level number, sets a value for PPD, which is points per dot, based on the level. So again, you've got level 1, 2, 3, 4 or above. So you get 5, 10, 10, 15, and then any level. If you manage to get past level 4, it's consistently 15 points per. Tells the screen about the points per dots, and that's because we have a level start screen here which shows you in this instrument the points per dot. So a simple piece of logic here takes that message and sets the instrument value, and then sets the delay again, so there's a delay before the game starts. And then in this is where the delay comes in. So the global logic, when it does a switch level, in any case, it will set this delay, which indicates that it's on this screen here, and no, sorry, it's on the game screen, and you move to the next level. So the game logic here will set this delay, and after this delay it will switch to the next level screen, which shows you the number of points per dot and gives you a chance to push a key to move on to the next level. So it's just again, housekeeping stuff. That's what that is. Switch screen to the level. So once the delay is completed, it's switch screen to the level screen and messages the location ID 1, which is start, I believe. Yep, so it tells the game to start. Move the cars into place, turn on the right ones depending on what level you're on. So as I mentioned earlier, there is a small amount of shared logic that's used in the game. These are just small subroutines where typically shared logic is used for places where you want to do the same sort of thing multiple times in different locations, to save on space and to keep logic looking a little bit tidier. So we've got 3 subgraphs in here. Current lane, which given an X and Y position and an X and Y direction of movement, so the X velocity and Y velocity from the cars, will work out which lane you're in. So it's as with most of these things, there's 2 very similar branches based on whether you're going horizontally or vertically. So first of all, it checks to see which direction you're going on. If you're going horizontally, it then comes in here, works out which direction you're going. Hold on, let me just check that again. Yeah, if it's not equal to 0, so if the X direction, if you're moving in the X, then it gets the Y position and works out which of the lanes you're in based on distance from the centre, effectively. So this is just doing some simple maths on the Y position, and it will spit out a lane number. Let me just go to the layout so you can see a lane number based on this or these, and it's based on the distance from the centre, so it mirrors nice and simply. So that's that one, and that's just used in a few places where it wants to. You probably have seen them. If I go to the car logic quickly and show the start here, it gets the current lane right at the initial place, and when you're doing lane changes, it gets the current lane and stores it into a variable, so it uses that subgraph. There's a snap to closest lane, which I explained when we were doing the shift, the swerve or the changing in lane motion. So this basically again we've got horizontal and vertical, so they're very similar, so I'll just focus on one. This just basically takes the position. So if you're moving horizontally, it takes the position vertically and snaps it to the nearest 16 pixels that corresponds to a track. So if the value is so that 56 and 128 are the 2 values that it needs to limit it to, the inside and the outside of the track range, and it itself uses a subroutine to keep things nice and simple, which is used all over the place. So again, these are broken off into a separate subroutine, and this snaps it to the nearest 16. So it takes the Y value based on which half of the track you're in, runs it through the snap to 16, which snaps it down to the nearest 16. I'll explain how that works in a moment, and then puts that into the output, and outputs an X and Y position. If you're moving horizontally, the X position doesn't change. If you're moving vertically, the Y position doesn't change. But it basically outputs an X and a Y new position that puts you in the middle of a track. So the last one, snap to 16, which is a very simple one, which just basically it takes the current position, works out if it's less than 8 pixels to the next increment of 16. If it is, it moves to that one. If it's less than 8 pixels, or less than 8 units from the previous increment of 16, it moves to that one, so it just moves to the closest one, and that just makes it's logical and feels natural that when you're not quite, you've barely moved across the lane, it snaps back to the one that you were in, and if you've almost completed a move but not quite, it snaps to the one that you were heading for. So that's just how they work, and again, as you can see, they keep things a little bit tidier, so rather than having lots of logic in here, it just calls through a subroutine and reads the values out, so keeps your logic a little bit less cluttered. So that's it. I think in a nutshell, that's pretty much how the game works. Fairly simple. As I say, it's not the most elegant of code. I could probably do a number of things a lot cleaner, and probably would if I went back and did it again. But it was a fairly simple game, thrown together fairly quickly. And if I just click this, you'll see I'm running so way below the memory limitations that I really wasn't too concerned about logic that would use a lot of memory or be inefficient. It works fine. It's fast enough, and it's fairly easy to follow ish. So that's basically it. I don't think there's anything else. There's some sound, there's screens. I've shown you the screens. Maybe just go into very quickly how the lives work. So the lives are 3 tile instruments. So you can see the type tile, and I set up a tile to match the 8x8 sprite for the car to use as the life indicator. And then in the logic for the screen, we've got a message handler. So the global logic will message the game screen, the main screen, when it loses a life on the crash handler, to say that lives have changed, and this will just go through all 3 and enable it or disable it depending on how many lives are left. So it just loops over life 1, life 2 and life 3, and if the number of lives remaining is greater than that, then set it to 12, which is the car, otherwise hide it. And that's how the lives indicator works. The score indicator is even simpler. It just takes a message again on ID 0, which the global logic will send to it to say that the score has changed with a value, and just sets the instrument value for here, this instrument. So fairly simple. And again, I'll make the game available initially to Patreon subscribers, so go and have a look, and if you've got any questions or thoughts about the way that I've done certain things, pop over to the Discord and let me know, and after a while it'll be made available to everybody via the Discord, so if you're interested in getting hold of it and having a play, keep an eye on the Discord. That's where I'll announce it. I think that's it for this one. Thanks. See you next time.